So welcome guys, welcome, good evening to all of you, and today we are sort of combining the solve a problem a day for 9th September, and because it was students doubt, and we will like merging the live problem solving and this for just today, and maybe we will doing it in the future, who knows. And yep, so if you have not solved the problem yet, do pause the video and solve it yourself and then come back to see the solution. Okay. Perfect. So coming back to our live batch of platinum, guys, are you like following the solve the problem a day every day, guys? All the 15, like 15, 16 people out here, just like say boom or yes, whatever you like to. Okay, good. Anyone else? Not anyone else following, or they're busy their own work? Okay, 2 people, 3 people, 4, 5. Good. Perfect. So yeah, it's like helping you to develop a habit of yours to help you solve problems, guys. Okay, so like it's very important for your own development and getting into a habitual practice of this. Anyways, let's get started with this problem. So I have selected this problem because it quite resonates with what we are learning right now, joint distributions, and let's see if it how to do this problem. So our students out here, I hope they have the necessary technology to deal with this problem. So we will go into it right away. So any ideas from you, guys? How will you deal with how will you do this problem? Any ideas from the auditorium? Any ideas from the audience? Like audience means for the students here live. Any ideas, guys? How will you like suppose this problem is given in ISI MStat PSB portion? So how will you approach this, guys? Tell me. Any ideas, guys? You're learning joint distributions, conditioning. Okay, conditioning. Nikhil is telling conditional. Satish is telling N is NBD. What is NBD? So we are given the distribution, individual distribution, the marginal distributions of x and y, and we need to find the joint PM of x and y. So x and y are IID themselves, okay, but n is dependent upon n is dependent upon x and y. So x and y are not dependent upon each other, but n is dependent upon x and y. Yeah, that's P of x into P of y, but how will you do it for like entire? It's like, so what do we mean when we tell we need to find the joint distribution, joint PMF of x, y, and n? We need to find this. Tell me what we need to find. So first step, what should I write, guys? Tell me. This is something you should learn. So you should tell me what is the first step I should write to find joint distribution of x, y, and n. What is the first step, guys? Tell me. If I ask you to find the joint distribution of x, y, and n, what is the first step? Good. We need to find that. We need to find this. We need to find the probability. That's what it means. That we need to find the probability that n is equal to small n, x is equal to small x, and y is equal to small y. This is what exactly we need to find, right? And you know the distribution of x, y, and you know the relationship between x, y, and n, right? So now tell me what's next. Like we know the distribution, marginal distributions of x, y, and n. You're right, Momita. We need to find the sample space for the PMF part. You're right. So here we can understand the range of the function is 0 to infinity. So because they are like 1 to infinity, it's like 1 comma 1 comma, it's like 1 to infinity cross 1 to infinity cross 1 to infinity. Let's not go into that. Let's just understand the probability directly. So how will you find it? Like, what's the first step, guys? How will you find this and focus on this? On this probability part. So Tishika is telling me to find n is equal to x plus y. It's fine, but what's how will you do this problem? Tell me. How will you find this? We need to do the next step. So what will be the next step? What do you think? What's the next step? We know that x, y, and n follows this. So we need to find the joint PM of x, y, and n. So what will be the next step, guys? What do you think? Any hint? We need to check whether they're independent or not. Okay, we check what are independent or not. It's right, but how does that help? We have an n over here. How does that help? Like, can nx and y, like can nx and y can take any values? Like, the first question to you is that, since you're not able to proceed it, can nx and y take all values? Yep. Can nx and y take all the values, guys? Yeah. Like, all the values means you randomly put any value of nx. Like, of course they are greater than or equal to 1, and like n is greater than or equal to 2 because x and y are minimum 1. But let's say n can take 5, x can take 2, and y can take 500. Can this happen? Like, n is equal to 2, n is equal to 5, x is equal to 2, and y is equal to 500. Can this happen? No. Why it cannot happen? N must be x plus y. Good. So therefore there is some intrinsic relationship between x, y, and n, right? So how do you mathematically pose it on this? Like, how do you mathematically pose it over here? What do you think? How can you mathematically inculcate over here into this equation? Any ideas? It's a very simple idea, guys. How will I deal with this problem? So n is related to x and y. So we can write this as probability x plus y is equal to n, x is equal to x, and y is equal to y. So okay, but so I have a very simple question. So I'm just asking, like, when we need to write. Okay, I mean, let's not go into conditioning. Let's just do it from the beginning only. Okay. So how we can, like, let's not go into given conditioning or whatever it is. Let's just do it. Wait. No, you're not understanding my problem. So what is the next step? What is the next step you're looking for? Okay, that's a good idea. But can you tell something over here from this equation? Like, don't think about conditioning, guys. Can you just directly tell something from here? Don't think about conditioning. Just let directly, can you say something from here? This is equal to, so if I say 5, let's take two cases, okay? If I 5, 2 and 500, this is 0, right? So therefore, for any nx and y, we can write this in terms of that this is 0 sometimes and non-zero sometimes. So I just wanted to write in that format. Yeah, you guys are all right. Good. That's a very good idea. Dishika, that's exactly what I wanted to understand. So therefore, when it's 0, guys, can you, when this probability is 0, can you tell me, guys, when this probability is 0? When this probability is 0? Show it is not equal to x plus y. Good, very good. So when n is not equal to x plus y. So therefore, if n is equal to x plus y, this will be something. So therefore, when n is equal to x plus y, this is what? This is probability. Can you just tell me what is this probability then? Qx plus y p square. No. Just write it in terms of like, if I tell that probability x plus y is equal to x plus y, comma x is equal to x, and y is equal to y, what is this probability equal to? Can you write it in simpler format? Can you write it in simpler format? It's very easy. It's like telling I have 4 oranges and 5 mangoes and 9 fruits. Is it like same like that? If I ask you, Very good. So it's same as asking, telling. It's like this automatically implies this. So this is like redundant. So it's same as this, right? Do all of you agree with this? And it can happen if and only if this happens. Like not here, but since given this data, it can only happen if this is equal to this. All of you understood this, guys? This is same as this. Yeah. So if you fix x and y, automatically n is fixed, right? If you fix x and y, automatically n is fixed. All of you agree with this or not, guys? Tell me. Did you understand this? Yeah, you're right, Debarshi. Yeah, you're right. But I'm not trying, like, I'm just fixing n on x and y, so it's like you're also right. All of you understood this? Therefore, we get this is equal to probability x is equal to x and y is equal to y. So this is probability x is equal to x and y is equal to y. Why I'm trying to do this? Because we want to convert the equation in terms of x and y because their distribution is easily known and they're independent. You understand? We don't want to convert it into something else. So since they're independent, it will be useful, no? So to understand that, we don't want to convert it into n and x, okay? Because they're dependent. We will convert it into x and y because they're independent. They're probably easier to calculate. That's where your problem-solving strategy will come up. Like, okay. So therefore, this is happening. All of you understood this simple idea is now we can easily find out this value, right? Why? Because we know it's equal to probability x is equal to x and y probability y is equal to y. So they're independent. We can use this property. So now see the difficulty. If I would have put, let's say I could have written like this also. Now probability, it's same as this. Probability x plus y or n is equal to x plus y and x is equal to x and y is equal to y. This can be written as in what format? Probability x is equal to x and y is equal to y. Or it can be written as probability n is equal to x plus y and x is equal to x. Or probability n is equal to x plus y and y is equal to y. You see, these two are x and y, x and n over are dependent, y and n over are dependent. So it will be really hard to calculate this joint distribution. It will take condition, but we are trying to convert it into something that is useful. That's where your creativity will come up. All of you understood the idea, guys. All of you understood the idea. Why this is much more helpful this way. Yeah? Good. So therefore, we get to find this. So therefore, we, without any conditioning, guys, that's why the conditioning question is given later on. That's why the conditioning question is given later on, okay? So don't think about the conditioning right away. Think about, understand the problem, okay? You will understand it much better. So that's why we have given a sequence. So we have understood this. We have found out the, like we can find out now this probability, which is equal to product of two geometric distribution ka PMF of that value. And that's easy. So now let's move on to the next part. We have to find out the joint distribution of probability n is equal to n and x is equal to x. Can you tell me what it is this now? Yes, exactly. I mean, is that that's what I told. Like, if I know that you have bought 4 mangoes and 5 oranges, I automatically know that you have bought 9 fruits. So if you add that variable, that's not adding any probabilistic information over here. So that's kind of redundant and like that's like you like yeah, that's redundant. Okay, that's redundant. Okay, it's like you have got into like it's like telling that you know you have passed class 12 in your but your resume you write that I have passed class 10 and 12. Because if you have passed class 12, then it automatically implies you have passed class 10, okay? So in that sense, like it automatically implies that. Okay, so now how will you write this? Any ideas? So the idea is that, can you convert it? Yes, exactly. So you have to convert it into here also in terms of x and y, because we understood that x and y is easier to handle x comma y than something like than non-x and like something else. So can we convert this problem into x and y? It's like telling I have bought 9 oranges and I have bought 4 like mangoes. So can we convert it into only oranges and mangoes? Can you? Yeah, can you convert into oranges and mangoes, guys? From fruits and oranges, you just to convert into mangoes and oranges. How can you do that? It's very easy. Bolo? Any ideas? It's very simple, guys. Yeah, but it's not. You need to find it in terms of n and small x, right? So how will you write that? Okay, but that doesn't help. That doesn't. We want to give it in terms of x comma y. So if you in terms, you have just written the information of n. So to convert it into x comma y. So how will you do that? You're on the right track. Very good. Superb. Superb. Perfect. That's the idea. Simple. I hope you understood the whole entire idea of doing it. Okay. So therefore we get that this is equal to probability x is equal to x and y is equal to this x plus y is equal to n. So x is equal to x automatically implies that its probability x is equal to x and y is equal to n minus x. So that's it. Simple. Like it's equal to this, and we know that it's therefore you can find out now probability x is equal to x and y is equal to n minus x since they're independent. So
both the problems answer will be same.
No.
Why not?
I mean, okay. So it depends upon like. I mean, I have tried to do it using like n and n equal to x plus y. So it will be a function of both n, x, and y. Okay. So how do you write this? So I will show you how to write this. Okay. So how to write this previous one? You write this as probability this is equal to probability x is equal to x and y is equal to like y, or y is equal to n, whatever you can write. Y is equal to y and n is equal to n. So you have written this in terms indicator small n is equal to x plus y. So it's dependent upon both n, x and y. Okay. And there's an indicator. I mean, if it's not that, then it's 0. So it's not same. You understand that it's a function of x, y, and n. Here it's a function of x and n. Okay, there's a difference. You understood? They have to mention the idea. So here it's a condition. There's a condition that n must be equal to x plus y. That condition is there. But here there is no such conditions. Did you understand, guys? Thank you for the question.
Writing y equals n minus x.
That's capital Y. That's a random variable. Here y is an observation. Y is a realization. Here it is coming in terms of this x small n, y small n. You can put 2, 5, and 7, like whatever here, and you will get an outcome in terms of 5, 2, and 5 ka function. But here you're putting two numbers, n and x, not y. Like the expression is same. See, the expression is same. But the problem is that here there is a condition extra. So they are not the same function. Do you understand, Ptolemy? Yeah?
That random variable y will take those values which will have value of n minus x. So the same thing happens in the previous problem also. Y takes values.
No, previous problem has an extra variable. So previous problem has 3 variables, n, x, and y. Here we have 2 variables, n and x. The probability is coming out to be same. I'm agreeing to that. But there is a condition, like there's an extra condition that this is 0 if this happens. There's a relationship between n and x and y. Here there is no y. Like if I tell you, like it's a function of n and small n and x. And here it's a function of small n, x, and y. So if I put a random n, x, and y, you will tell either like you have to like decide whether n is equal to x plus y, and then you have to find the probability. But if I put random n, x, and y, it doesn't care about what y is, because there's no y over here. There's no relation of y over here. Like we're transferring it into this variable. But there's only, we are realizing two random variables, n and x. We are for calculating the probability, we are converting into this. But actually, it's two random variables. Like the random variable here is capital N and x. Okay, the joint distribution n and x. So we are converting into x and y the joint distribution by telling that these two events are same. So we are telling that. So we are trying to find the joint distribution n and x. Okay. So we are telling this event that n is equal to n and x is equal to x is actually same as the event x is equal to x and y is equal to n minus x, and therefore their probability is equal. But we are from the very beginning interested in the probability of this, not this. This is just for calculation purposes. And here from the very beginning we interest the probability of all three of them together. So they are different. Their probability can come out to be same, but they are fundamentally different. Did you understand this, guys? All of you understood this? This is a very good question, but did you understand like what I explained? If not, I will explain it again. Yeah? Okay. Sure. So tell me what you didn't understand, Satej, so that I will ask Paul to like make you understand. No. Acha, understand this very fundamentally. It's like, you remember how I drew the joint distribution, the PMF? We drew that x is equal to here, y is equal to here, and these are numbers over here. Okay. So these are the probabilities. So x and y and z will be there is another random vertical dimension z, and you will write a in cube format. Okay. So the probability values can be same, but understand this. Like, I mean, the problem is that here that is a function of three variables. This is a function of three variables. It's a function of two variables, guys. It's a function of two variables. There's an intricate relationship between n, x, and y. That's true. But here is a function of two random, like function of two variables. There is a function of three variables in joint distribution of three random numbers. Like, what is the fundamental issue you're having? I am not understanding. You can tell me once again. Anvesha, what is your doubt? Can you tell me again? I cannot understand. Like, why this will be plus? I didn't get you. Can you just explain what is going on in your mind so that I can understand your viewpoint? Can you unmute yourself if it's possible for you?
Because okay, so sir, you said that it's a two variable function, but here we need to find x, y, and n is follows another distribution. So it's we can define n as a third variable, and you are getting the probability of x and n and f probability of y and n. Then it means f of x, y, n equals to f of x, n and f of y, n.
Yeah, see, understand.
I'm just asking that.
So exactly. We can also write it in this format also. Understand? Let's understand this. This is a probability symbol. Understand? This is a function of x and n. They are very interested in understanding this. This is the two things are different. Here is a function of x, y, and n. These two are different things. Their values are same. No, their values are actually not same, because I mean, if n is something like not equal to x plus I, it will be 0, but there is no value over here 0. So these are all equal in terms of event, but not in terms of probability. Like this can only, like, did you understand? These two are fundamentally different. Did you understand this? Do you understand this, guys? Anvesha?
Yes.
I mean, फिर से बोलो, like tell me once again what is the like.
I have a little bit confusion.
बोलो. Sure.
That why is the difference between a probability of x equals to x, y equals to n minus x, and capital N equals to small n, and probability of x equals to x, capital Y equals to small y, and capital Y equals to small?
They are the same probability. They are the same event.
In two cases, n defines x plus y. Where is the difference?
Oh, see. I understood your doubt. So you're telling that, see this. So your doubt is what, that these two are same. Your doubt is that these two are same. Yeah.
No, in the second line, if we are engaging y equals to n minus x, then it will be same.
Yeah, of course it will be same.
Then
Yeah.
f of x comma n equals to f of x, y, and n. Here is my doubt.
So these are all events, okay? So here it's probability n is equal to n. Here it's probability x is equal to x and y is equal to x n minus x. So, and here it's probability x is equal to x, y is equal to n minus x, and n is equal to n. Like I'm not.
Yes, in the second line, probability of x equals to x and y equals to n minus n x. When if we can write this when x plus y equals to n. Otherwise, if n equals to x into y, then y equals to n by x. So the probability are same.
Like, can you repeat the last line? If n is equal to x plus y.
Means, in the second part, the probability of x equals to x, comma y equals to n minus x. When we can write this? When x plus y equals to n.
Yeah, that is the, like, what is n? N is over here like x plus y. So x plus y of course is equal to n. N is
exactly. Then if x y n equals to f x comma n.
So there is no capital. These are random variable. Wait. So I am telling the following. So it's like telling this. Probability capital X random variable is taking 2 and capital N random variable is taking 3, 5 is same as probability. Here I'm just replacing 2 by 6 and small y by 5. I'm telling that x is equal to x plus y is equal to 5, which is same as probability x is equal to 2 and y is equal to 3. Okay. So now tell me the next doubt. This is same as again probability x is equal to 2, y is equal to 3 and n is equal to 5. These all four are equal. Now tell me the next doubt, guys. Now Anvesha, tell me, what is your doubt?
Okay, I can understand.
Polumi, what is your doubt, guys? Satej, what is your doubt? So I am telling this is not equal to probability x is equal to 2, y is equal to, like, sorry, y is equal to y and n is equal to 5. Why? Because there's an extra variable y. If I put y is equal to 500, this will turn out to be 0. So there is an extra variable y. So this is not equal to this. So it's a function of g of 2 comma 5, like x comma y, where I'm putting like it's g of 2 comma 5, but here it's h of 2 comma y comma 5. There's another variable. Now if y is equal to 5 minus 2, then only it will give this, like h of 2 comma y comma 5 is equal to g of 2 comma 5 if y is equal to 5 minus 2 is equal to 0 otherwise. You understand, guys?
Yeah, and then the G25 is the answer for the second problem.
Yeah, G25 is the answer for the second problem. You're right.
Yeah, means what I was saying that the probability value which we will get for A, question number A is same as the probability value of question number D.
No, it will not be same.
Yeah, means there is an extra condition of 0 when n not equals.
Yeah, that means they're not same.
Okay.
I mean, yeah, I mean, whatever like value you put in, if you can, even if you put same, like, see, understand, if you put n is equal to As I told, if you put n is equal to 2, n equal to 5 and x is equal to 2, in both of this, okay, they will be equal only if y is equal to 5 minus 2, 0 otherwise. They are equal, but only in this case. So that means they are not equal, always. So h25 is not equal to this, but they are equal given y is equal to 5 minus 2. So it's like they are equal if given y is equal to like whatever. Like, I hope you understood, all of you. Yeah. I think we're actually getting confused with the small variable x and capital variable x. Everything clear, guys? Good. Okay, for Rakesh, Rishabh, it's going fine.
Yes, sir.
Okay, fine. Good. So let's move to the next idea. So let's see what the next problem is. The next idea is now conditional probability. So what is the conditional PMF? That x given n is equal to n and give a simple description of what it results as. The conditional PMF, okay? So it's like asking you to find the following probability. That probability, capital X is equal to small x, given capital N is equal to n, small n. Okay? So how will you do this? That means you want to understand what? So how do you calculate conditional how do you calculate conditional probability, guys? How will you calculate this? So you already know what? You already know what? So you already know. Can you use the previous? Yes, we have a joint and a marginal distribution. Very good. So you need to convert it into joint and marginal. How? And we know the distribution of both of them. We have just calculated this, and we know this because n follows sum of two geometric. So n will be a binomial distribution. So a negative binomial distribution. So you can write down their PMF. You can write down their PMF, and you can find this out. All of you understood this, guys? You understood this? It's very simple. So conditional PMF is nothing but it's like a use of marginal and joint distribution. So therefore, conditional distribution is a function of joint and marginal distribution. So if you want to know joint distribution, if you want to know marginal distribution of all the variables, you can find the conditional distribution. That's how it's defined. So therefore, conditional distribution is just a corollary of joint and marginal distribution, guys. So it's very simple, very, very simple. Okay, everything clear? Everything clear? Can I move on to the next problem? Okay, perfect. So now this is not a problem of the day. So you can just like see the watch, continue watching, or you can just move ahead to the next. You can just you can close the video if you're not interested in the other problem discussions. Okay, so coming back to the rest of the problems that I have planned. So Tishika has given me some problem idea, like some problem that she has. So if you guys send me problem yourself, I will solve it real time. Okay, so like you can discuss in the group, or you can send me personally. So that will be helping you to discuss problems. So it's a real analysis problem, okay, and I don't know how to solve it, frankly. Okay. But okay, so okay, I will just discuss the easier ones for this now. These are real analysis problems, and let's do this. It may be a good refreshment for you. See, I will tell you this joint distribution and something like this are really not a hard problem. Okay, these are very, very easy problem. The only tricky part, in fact, is the Adams law and the Eve's law. Okay, which is called the smoothing expectation, which I think Shohomda will teach you. and those are really useful and very beautiful. So otherwise it's just normal problem solving, okay? So you just practice and joint distribution is really easy, okay? And it's the basis of regression techniques that we'll learn in the statistics course, okay? In fact, like they will teach you. Okay, so let's do this problem. I will give hints. Okay guys, I'm just asking a general question, like I will just do a poll, like how much you're confident in probability? You're confident in probability, right? Can you do problems yourself with like bad, fair, good, very confident? So please give the poll so that I can understand you and correspondingly guide you towards your like preparation. Can you see the poll, guys? Okay, 1 is bad, 1 fair, 1 good, 2 fair, 3 fair. Fair is a very good option, very safe option. When you don't know about that, that's like sort of the expected value. Okay, good. So the person who is bad, that person must contact me personally after the class. I can give him or her some ideas about how to proceed. Okay, that if you're good, if you think you're okay, if you're bad, then you're like, please contact me, okay, after the class. Okay, if you're fair, then solve problems, guys. So one major issue I'm seeing, in fact, students have told me after doing the mock test is the following, that they are doing a lot of silly mistakes. So I have a suggestion for you. What will you do if you're doing a lot of silly mistakes? It's a very common mistake I do, everyone does. So what you do is that, you know, why you do silly mistakes? Suppose I ask you to do a problem in 1 hour, or if I ask you to do the same problem in 5 minutes, you will do the mistake. So why is this silly mistake coming up? It's not a silly mistake. It's a silly mistake because you have less time. So if you remove the condition of time, it will not be a silly mistake. So how to avoid a silly mistake? So take a problem, take any problem, and oh, my voice is breaking in between. Is it fine now? Is it fine now? Okay. Okay, anyway, so just a suggestion, like what if you are doing silly mistake? I think if you're doing silly mistake, you take any random problem, okay? So any random problem, and you think you can solve, you believe that you can solve, okay, and you give a time bound to it, let's say 10 minutes or 5 minutes. So select a problem that you can do, you think you can do, by seeing a problem you think you can do, right? Let's say you take a very easy problem, but you think you can do it. So take a problem, you think you can do it, give a time bound to it, and try to solve it. And do it within the time bound, okay? That's a game with yourself only, okay? And once you set the time bound, if you do it, it's good. If you do it, you must develop the habit, and I think it will really good. You give you good like outputs. I think that's one of the ways. I think that works. So anyone who tried this method, I think I suggested someone. I forgot the name. Anyone who tried this after I suggested him or her? Did you try out the person I suggested? Forgot the name. Okay. Okay, please try out. Oh yeah, you're China. Yeah, so please try out China. Okay, so it's very important. And although if you're making silly mistakes, please do try out this method. If it doesn't work out, I have to think of some other method. Okay, so you can try this out, and I think that can really help. But if you're not understanding, if you think you're weak, this is after you feel that you're good. Okay, so confident is the key place, the time when you think you can solve it within time. Good is the time when you can solve it, but you cannot making silly mistakes while giving time bounds. Fair is like you're in okay position, you're not sure, and bad is like really bad. I mean, you are not clear with the concept. So if you're in the bad position, go and clear your concepts and attend some problems, see the solutions. and then if you're in a fair position, go and make yourself a good problem solving, like develop your problem solving. I think your theory is good, but you cannot solve problems, so solve more problems from the books. If it's good, then just give time bound and become confident. These are the 5 steps, like 3-4 steps I can suggest you to do this. Okay, so coming back to this problem, if you are really focused and not listening to my gyan, I think you must have tried out this problem in between. So any ideas on how you have tried out this problem, guys? Any ideas? So Tishika, since it's a doubt, any ideas like how you tried out this problem? How you tried this out?
So in the first question, first I tried by putting y is equal to 0. But then I thought that f of x is not equal to 0, then I thought that this would not be the case. I should try this.
Okay. Fine. So the way to do it. So let's do first one. F of x plus y is equal to fx times fy for all our x1 and real, and fx not equal to 0 for any x in R. So fx is differentiable at x at 0 and f dash is 0. F dash 0 is 2 and it's defined for all x and y. So how do you do this? So can you give a function which follows this property? Can you give an idea of a function which follows this property, guys?
That is multiplication, fx into fy.
Yeah.
Logarithm.
Yeah. You're close to that. That's not true. It's inverse. Yeah, it's inverse of logarithm. So e to the power x plus y. For whatever Polomy was saying, or I think it was Polomy, I'm not sure. For logarithm, it's this, not this. Logarithm. So if it's a logarithm one, then the first thing we should show is that it's greater than or equal to 0. So do you think it's greater than or equal to 0? Like the value fx is greater than or equal to 0. So let's try to understand whether x, what is like. So let's try to understand like the value of fx. So take an example and you try to prove the properties of that example. Okay, that's how you solve this type of problem. So value of fx, so greater than or equal to 0. Can you prove it? Anyhow, it's very easy. It's very easy. Any ideas? Yeah, but
from the graph of e to the power x, we can say that it's an increasing graph.
No. I'm not asking you to prove that e to the power x is a greater than or equal to.
We can take the derivative and f dash x is.
No. If we have not proved that fx is only differentiable at x equal to 0. It's not given that fx is differentiable everywhere.
Okay.
It's simple algebra. It's like use your class 10 algebraic ideas, mathematics ideas. Don't think about it too much in terms of derivative and stuff. Show that this is greater than or equal to 0.
Put y equals 0 in f of x plus 1.
Okay, so get f of x is equal to f of x into f of y, f of 0 minus 1. So
if we take e to the power x, then f dash 0 will do.
number 1, e to the power x is a bit of a solution. You don't know whether it's a solution or not. Number 2, f dash x is not defined for all the x. So don't take this. Use high school algebra, as I told. So you just show that fx is equal to greater than equal to 0. So there is a very famous inequality. Some inequality is greater than equal to 0. What is that? Something is always greater than equal to 0. What is that? Any variable का some function. बोलो.
Even square.
So what should I write it? You're right. So what should I write here? X square is always greater than equal to 0. Right? So can you find it in terms of some square?
E to the power 2x.
E to the power कहाँ आ रहा है? You don't understand. E to the power x is a sample example. I took the motivation that from e to the power x to show that, like, to get an idea, okay, if x can be greater than equal to 0, but it is not. Why you are putting e to the power x into fx? That's a part of it. That's not always the true. Like, you have to show that it's actually equal to e to the power x. You don't know whether it's equal to the power x or not. You understood, Tishika? Don't make this mistake. Don't you realize that? Did you understand?
Yes.
So can you?
Mod of f.
क्या 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 बोलो फिर से?
Sir, mod of f of x.
Mod of f of x. Fx equal to mod of f of x.
Definitely.
Huh? You're telling fx is equal to mod of f of x. So I'm just telling you, try to find its fx in terms of a square. Use this property, man. It's very easy. I'm telling you, Barbar, it's just high school algebra.
Yeah, sir, just replace y by x will be f of 2x equals x square.
You're right, very close, but we don't need f of 2x, we need f of x. So what we will do? You're right.
X multiplied by f of 0. No, sorry.
Satej is right. Nikhil is right, actually. Sorry. So can you just convert that 2x into x somehow? You're on the right track. It's a game. It's a quiz. It's a puzzle. So he's telling f of 2x is equal to f of x into f of x. That is f of x squared. Can you replace f of 2x by f of x? Somehow. You just are 1% away from the solution. You just put x is equal to x by 2 and y is equal to y by 2. So you get it's f of x by 2 into f of x by 2. That is, it's a whole square. Did you get it, guys? Isn't that simple? And you were thinking of derivative? You understood it, all of you? The y is greater than or equal to 0?
Yes, but what we are trying to do here, we are trying to show it greater than equal 0.
So it's like we are trying to show greater than or equal to 0 because let's see why it will be helpful. So next step is always find out f of trivial values. So it's greater than or equal to 0. Let's find out f of 0. What is f of 0? So put x is equal to 0, y is equal to 0, you get f of 0 square is equal to f of 0. From here you know that if no one value takes 0 value, so f of 0 must be equal to 1. We got this. So we got f of 0 is equal to 1 and we got f of x is greater than or equal to 0 always. So what we know, why we took f of greater than or equal to 0 and it's not greater than or equal to 0, it's greater than 0 because no value will take 0, it's given. So it's always greater than 0. So why we take 2 greater than 0? It's very simple. So that we can take log of it. So you can take log of it. So log of f of x y is equal to log of f of x plus log of f of y. If we wouldn't have shown that it's greater than 0, we couldn't have taken log, right? So that's always a good step to start with. And this, if you write it as log of f of x, you can define it as h of x. So it's h of x plus y is equal to h of x plus h of y. So to convert it into somehow interesting stuff, now we can convert it into derivatives now. Why? Because derivative of h is needed now. Because y derivative was of this form, right? X plus h minus x. Let's call it g. We want this, right? G of x plus h minus gx by h. Now from this we know g of x plus h is equal to g of x plus g of h. This is equal to what? G of h is equal to g of h by h. Right? And can we find out f of x, f dash of 0 from here to g dash of 0? Is it possible? What is g dash of 0? Can you just tell me? Let's understand g dash of 0. So that there are like, let's understand z of 0. So what is g of 0? Can you just tell me, guys, what is g of 0? G of 0 is what? Log of f of 0. What is f of 0, guys? F of 0 is 1. So g of 0 is 1, 0. So you can write it as g of h minus g of 0 by h. Right? Now you know that fx is differentiable at 0. And you know that fx is equal to log of f of x is g of x. So therefore g dash of x is what? Yes? F dash of x by f of x. So therefore g dash of 0 is what? F dash of 0 by f of 0. So f dash of 0 is what? 2. So it's 2 by 1, which is 2. So you know g dash of 0. So therefore if you now put limit h and 0 over here, if you put limit h and 0 over here, you get that this is equal to g dash of 0, which is equal to 2. So what do you get? That limit, like g dash of x exists for all x, and it will imply f dash of x, f dash exists for all x, and we got that g dash of x is equal to 2, and g of x is what? Log of fx is equal to 2. Sorry, g dash x is what? F dash of x by fx is equal to 2. And we have got what? F dash x is equal to twice fx now. Right? That's exactly what is needed over here. And hence determine fx. So you know, do integration on both sides. So you get that here it's what? It's f of x plus is equal to 2 plus some constant. Like, I think you can do it from, I mean, you can now do an indefinite integration over here. Let's say 0 to y or z, 0 to z dx. So you get f of z. This is what f of z, right? Oh, I'm so sorry. I think I'm doing some mistake. What you can also do is like this.
So will this be log f of x?
Yeah, you're right. Log f of x, you're right. So not writing like that. Let's write it like this. Say it's f dash x, like g dash x is equal to 0. So you get what? Gx is equal to what? By integration 2x plus something, but g of 0 is equal to 0, so it's 2x. Therefore, fx is what? Log fx is equal to 2x. So you get what? Fx is equal to e to the power 2x. Did you understand, guys? All of you understood the solution?
The gx equals to 2x from there.
Gx is equal to log of fx. Gx is log of fx, and we therefore took e to the power on both sides to get fx on left hand side and e to the power 2x on right hand side. Do you understand?
Okay, and that one I have got till g dash of 0, we got 2. Then after that, what we did to find g dash of x?
So g dash of x is equal to 2, so we integrated it on both sides. To get g of gx is equal to 2x plus some constant by indefinite integration. But that constant, it doesn't matter because g of 0 is equal to therefore c, and g of 0 we know is 0, so c must be equal to 0. So therefore g of x is equal to 2x therefore. Did you understand?
So that we got g dash of x equals 2. Means that transition was missed.
You didn't understand why g of x is equal to 2?
In last page, I got till g dash of 0 equals 2.
Oh, so I proved that g of x is equal to g dash of 0. So g of x plus h minus g of x is what? G of h by h. Now this is what? G of h minus g of 0 by h. Now if you put limit h and 0 on both sides, what do you get? You get here g dash of x and here you get g dash of 0. So you get g dash of x is equal to g dash of 0. Did you understand, guys? All of you? Dev, Mansi, Nikhil, Paulami, Pratik, Pratiksha, Rakesh, Romas, Shoikot. So hi Shoikot, I think it's your first class too. I hope you're understanding. I'm sorry, I sort of missed you, I don't know why. Shana, Shuprava, Tishika, all of you understood? Good. So do you want me to do other problems also this? Do you want me to do this? Huh, Tishika?
I try once more, then I ask you if I didn't get that.
Oh, hi Dev. Actually, so many hi Dev also. Actually, I will talk to you. So Nikhil, not Nikhil, so Rishabh, Shoikot, Rakesh, and Dev, all four of your new class. So I will talk to you after this class, okay? That's good actually. Tishika, so where are these problems from? Nikhil is asking.
It's a Samvedna book.
क्या book?
Samvedna author है.
क्या?
I'll write it in chat box.
Okay, okay. So do you want me to do more probability problem or mathematics problems? Bolo.
Some mix of both the topics.
Okay, I mean, I think we can do another one problem.
Problem from the real answer or real zero that we won't lose any hold on that. Those
क्या?
topics.
क्या?
You can take one problem of real analysis or linear algebra in a week so that we don't lose any hold on in those topics.
Yeah, I understand. Like, what I will do now is asking whether I will give a problem of my own or do you have other problems to like me to discuss, for me to discuss. Do you want to discuss that ISI problem that Uttaran shared in the group?
Yes, sir.
Okay, it's a very interesting problem. Um, the problem is a bit more involved, okay, bit difficult, so make sure you understand the problem well. So there are multiple steps, so that's why a diagram is needed for this type of problem, okay. So for that, I'm assuming you have to know like continuous joint random variable, which I haven't taught till now. So like it will be taught soon, but I will use the ideas because there's a conditional like both of them. Anyway, so let's understand the problem. So a random variable z is being formed. Understand this, like whenever you're doing this problem, do a tree diagram. A random variable z is formed and x follows uniform 0 1. So we know, so understand what we know. We know x, we know y given x is equal to x. इसका distribution we know. So y is defined to be x. If y is equal to 1, then z is equal to x. Otherwise, the experiment is repeated until a pair x and y is got with y is equal to 1 obtained. Very like complicated procedure. Understand this very carefully. What is happening? So here we are trying to understand y. So here is y. If y is equal to 1, then z is equal to x. Like uniform 0 1. Understand the tree diagram very well, okay? It's very important. And if else, if y is equal to 0, then we repeat y. To get 1, to get z is equal to x. So you can get a hint of geometric property here. But there's a problem. The problem is that y is again dependent upon x. Y given x is following some value, so y is dependent upon x. So we don't know the distribution of y unless, so see, what we know is that we want to know the distribution of y. What we know here, we know x, this, and we know x. We know x given x, we know x. How do you understand, how do you know the distribution of y then? Can someone tell me, if we know x given y is equal to a, y given x equal to x and capital X, how we can get the value of y? Just tell me in terms of probability. So we want to find the probability of y. So what do we need from here? Mansi is telling that we can't find joint distribution, marginal, LOTP, okay. So from these two values, what do we get, guys? What can we get? So what are the things?
We can get joint distribution from these two.
Okay, so let's understand this. We are given this. We are given this too. From this we can create what? We can create this value. We know probability of this. Let's understand this very carefully. We know the probability of this. We know probability this. From this what we can create? Can we create probability x is equal to x and y is equal to y? Can we create probability y is equal to y? Can we create probability x is equal to x given y is equal to y? What we can create? Can we create all of them? Tell me, this is an important problem solving strategy. Can we create all of them? Yeah? Can we create all of them? What do you think, guys? How? We can create joint distribution by probability y is equal to y given x is equal to x into probability x is equal to x. Maybe if, see here probability x is equal to x is not a good idea because here x is a joint continuous distribution. So we need to find it in terms of density. Like here it's a bit of a problem because one is one is discrete, one is continuous. So a bit of a problem is over here. But we can find this idea. We can find sort of joint distribution. We can find sort of this. So can we find this? We can find this, of course, by using. So we want to find probability y. Now y is equal to, y can take what values? Y is a boundary random variable. Y given x is equal to boundary random variable. So therefore, we can only find, so probability y is equal to y is therefore what? It can only take positive value if y is equal to 1. So y also is a boundary random variable. Let's understand probability, like it's a discrete random variable. Let's say we want to find probability y is equal to y. So we want to, therefore how we do it? So it can happen like, we need to find the marginal, right? It can take what? So we know probability y is equal to y given x is equal to x. We know this. And we will merge it, like we will multiply with this with the distribution of x. And we integrate it over x. Instead of the sum. 0 to 1. It's like it's a law of lower probability. So we should have done this, but since x is a continuous random variable here, we should have done this. But since x is a continuous random variable over here, we have to integrate it. But understand this value is therefore non-zero only if y is equal to 1 and 0. So therefore, y itself a boundary random variable because it's taking 0 or 1 value. So some probability p we don't know, p dash j. So therefore we need to find out probability y is equal to 1, which is indicator 0 to 1, probability y is equal to 1 given x into f of x dx, which is equal to what? This is equal to 1 because it's uniform. Uska PDF is 1, and this is what? This is given that y given x is equal to x is Bernoulli with probability of success x. So therefore this is what? Probability y is equal to 1 is x itself. So what we get? We get x square by 2, so we get half. Similarly, probability y is equal to 0 is what? Integration, it should be half because it's a Bernoulli. Let's see. Y is equal to 0 given x is equal to x, so it's 1 minus x dx, so it is equal to half. So therefore y follows Bernoulli half. All of you understood till this point of time, guys? Did you understand this? It's a very important step. Did you understand, guys?
Sir, again the y equals 0, that case.
Yeah. Oh, that case. See, y is equal to 1 with probability y is equal to, given x is equal to x, y is equal to 1 with probability x. So therefore y is equal to 1 with probability 1 minus x. Y is equal to 0 with probability 1 minus x, right?
Yeah, yes.
So therefore I put 1 minus x over here, and f of x is 1 because it's a uniform random variable x, 0 comma 1. Therefore, 1 minus x, the integration will be half. You can check that. Did you understand, Nikhil? Anvesha, Dev,
Yes.
Mansi, Nikhil, Paulami, Pratik, Pratiksha, Proma, Rakesh, Rishabh, Shoigat, Satej, Shana, Tishika, and Shupro. Did you understand? However, the y will take only 0. Oh, so if you take any other value, let's say small y. Now we know that y given x only takes 0 and y. So if you put y is equal to 1000, let's say, it will be 0. So y, this probability is 0 if y is not 0 and 1. So therefore this integration turns out to be 0 only. Do you understand, Satej? So Rakesh, Rishabh, are you understanding? Shana, are you understanding? Okay, so we have got this. So we have got the distribution of y. Y itself is a, so therefore what we have got. Let's try to understand this. So we have understood that y follows Bernoulli half. We have understood that y given x is equal to x follows Bernoulli x. We have got x follows uniform 0, 1. Let's try to understand the experiment now once again. We are telling now that let's do y. So y is now just a coin toss. So let's coin the toss of y. Like toss the coin, sorry. If it's equal to 1, then z is equal to x. You're tossing y, and if it's equal to 1, z is equal to x. Okay? If it's 0, we continue tossing it till we get 1. And once we get 1, what we get? We get z is equal to x again. So we can get z is equal to x in two different ways. Once in this way, once in that way. But at the end of the day, z must be equal to x. Right? All of you understood this. At the end of the day, z must be equal to x. Did you understand this? Oh, my voice is breaking. Is it fine now? Is it fine now? Okay, so my question is the following. That, yeah, I am repeating it, don't worry. So, we first toss y. Sure. We first toss y. Okay. So, if y is equal to 1, then z is equal to x. We define a new random variable z is equal to x. If y is equal to 0, we toss it again. We toss it again till we get 1. And once we get 1, we define z is equal to x. Right? So at the end of the day, z is actually equal to x, but in two different ways. So z is actually not equal to x, z is something a bit different. We are getting z is equal to x in two different ways. Did you understand this part? Finally, we have to put z is equal to x. Because we are stopping when only y is equal to 1. But y is equal to 1 in? So what is this? So y is equal to 1 in how many steps? So now, there is another latent variable here. So we have got the distribution. There is another latent variable here. What is the variable? Let's call it g, in the name of geometric. So what is telling? So therefore understand it very carefully. Let's say, what can happen? So this is the idea. You're tossing the coin of y. Let's do the first trial. It can happen in one step, first step only, y is equal to 1, and then z is equal to x. In the second step, or it can happen y is equal to 0, and then y is equal to 1, and then z is equal to x. So we need to find what? We need to find the density of z, right? We need to find the density of z. Let's try to understand in terms of cumulative density. We need to find this. But it is dependent upon this latent random variable g. So y is not the problem here. The problem is this g. So this is the idea. So therefore, understand this. Understand this very carefully. What is happening? Understand this very carefully. This is latent variable g. So y, using the Bernoulli toss y, we are defining a new random variable g unknowingly. So what we are telling? We have this y random variable. So now what we are telling that x is equal to z is equal to x. At that point of time, we get, like, whatever point of time we get is equal to z is equal to x. So how is this depend? How do we find this value then? How do we find this value? Any ideas? Let's read the problem again. There's a bit of a problem here. The experiment is started afresh. Okay? So this is not the experiment. So understand this very carefully. What is happening? This is not starting afresh. This is like what is happening again. Understand this very carefully. We first toss x. We realize that x gives x value. Okay? Then we toss y. Okay? Then we toss y. If we get 1, we get z is equal to x. So understand this very carefully. Okay, now you have to understand the whole dynamics. We first toss x. We first do x. Pick a random number from uniform 0, 1. Life is not so easy. Why we got stuck there? Because we didn't understand the dynamics. So first we put a random number from uniform 0, 1. Now we toss a coin toss y given x equal to x following probability Bernoulli x, and we get 1. If we get 1, we assign z is equal to this initial x. If not, then what we do? We go back to this initial x is equal to x. Now you understood the dynamics. We start the whole thing afresh. Okay? So we first pick a random number from uniform 0, 1. Now with that number as probability, we toss a coin. If we get in the 1 in that toss, we assign the new random variable z is equal to that small x we started with. If it's 0, we start the entire experiment again. All of you got this experiment clear now. This was the thing. If you don't understand the experiment and do these things randomly, this is exactly where you will come and you will not understand what to do. And that's why I did it for you, to show you, to mislead you to understanding that if you do without understanding the experiment initially, you have to do some extra work. Did you understand the experiment now? All of you understood the experiment now? Sure. Very important one. We first take a random number from 0, 1. With that probability, I toss a coin. If it comes out to be 1, we assign the random variable z that initial x value. If it turns out to be 0, we delete everything from our memory and start afresh again. Afresh. Okay? This is what the experiment is. Now we need to find probability, or rather, let's say probability, or let's say probability z less than equal to z, small z. How do we find it? So we have two ways of doing it. It's going like this or going like this. So there's a never-ending procedure over here. How do you tackle this type of scenario?
We have got probability of y equals 1 equals half, y equal to 0 equals half. That means if the condition of x is removed, then y will follow normal means.
Wait. See, the problem is that z is dependent upon x, so we cannot forget x. So it's like we cannot forget x, okay? Because z is retaining the value of x. So even if by doing marginal, we are forgetting the value of x actually. So it's not good because z is retaining. You understand? If we forget x and we start from the beginning, it's of no value because we don't know what x was. When we are doing marginal, what is essentially the idea? We are forgetting how y is dependent upon x when we are doing the marginal. But if we forget how y is dependent upon x, how we can assign the value to this z if we don't know what x we started with? You understood? If you don't know with what x we started with, how we can assign a value to z? So this is important. So how do you approach this, guys? Any ideas? Yeah, Polam, you were saying something?
Yes, I have understood that x is important here. I am asking that if in any other problem y given x is given like this situation, so without solving anything, can we say that simple marginal of y will be Bernoulli with probability half?
Yeah, that we can say, of course, that we have proved. But I proved it just to make you understand that just since you have data over there, you will just find out the probability of y. That will not help. You have to understand the experiment itself to proceed towards the problem. Here, y is equal to half will not help because we are losing the value, the information of data of x. So let's not blindly go into doing mathematics like the problems since you know the formulas. Let's understand the whole problem itself. Okay? Maybe we don't need to spend that time on y. We need to do something else. Okay? Okay, so understand this very carefully. Okay, guys. Let's say we're going to find the density of z. That means sort of z has come up. Like z is equal to like x has z is equal to like x is equal to z has come up. Okay, in some sense, idea. Let's think about in that way. That is conditioned on what? That is conditioned on the fact of how many tosses meat has come. How many tosses meat has come, it matters on that. Right? How many tosses meat has come, it matters on that. Did you understand? So how will you do this problem? How will you approach this problem, guys? So it's like this. Let's say we have got x is equal to 0.3. We find a problem, like we do it with y is equal to, like we roll y with probability 0.3 and we get 1, we get z is equal to x. So you understand if the value of x is higher. Okay, understand this very carefully logically. If value of x turns out to be higher, the probability of y is equal to 1 is higher because we have, like, if I say, if in the first, like this experiment, we pick up x, we get 0.9, so we toss y with Bernoulli 0.9, the probability of getting 1 is higher, right? So therefore the probability of here z is equal to getting lower value of z is lower than getting, so it will be a skewed distribution like this. The probability of getting lower value of z is less because why? Let's say probability of getting z is equal to 0.2, around 0.2. That means what? That means x has been around 0.2. That means what? Y has given, like y is being like tossed with Bernoulli 0.2, around 0.2. That means what? Like that is a very small rare event. So the probability will be less. So here the probability of this occurring is very less, of one occurring. But rather here probability of occurring is more. Why? Because 0.9, if it's we are trying to understand whether z is around 0.9, try to understand probabilistically. Okay, like real life, what is happening? If we are trying to find probability that z is around 0.9, that means x has turned out to be around 0.9. Otherwise, we wouldn't have given x z is equal to x. If it turns out 0.9, then we're trying to understand. We are tossing a coin with probability 0.1. Then only it's y का 1 आने का probability is ज़्यादा है than y is equal to like 0.2 के around. Did you understand this idea? This idea, did you understand? I'm just doing mathematics. I'm just telling you stories, mathematical stories. Did you understand this idea, guys? Like probability of z being around 0.2 is less than probability of z being around 0.9. Did you understand this? Please tell me yes or no. Yes? No? There is no answer. Sure. So what is happening? So it's like this. So we first see x, we observe x, let's say we have got x equal to 0.2. What we do? We toss a coin with Bernoulli 0.2. If we get 1, we like assign z is equal to 0.2. If we get 0, we turn to the next experiment where let's say we have got x equal to 0.9 and we get y given x is equal to x. Then we do Bernoulli 0.9. ये 1 आ गया. If it's 1, then 0 is equal to 0.9 and 0. मैं अगर फिर से शुरू कर दूंगा. Okay. That means what? ये this probability is much more than this path. Which path is much more probable? This path is much more probable. Why? Because यहाँ पर 0 आने का probability is less, 0.1. यहाँ पर 0 आने का probability is 0.8. So ये ना होने का, this of this not happening is much more. Of this happening is like not happening is much less here. So therefore z will be likely to be around 0.9 than around 0.2. Did you understand this now? All of you. Nikhil, did you understand? Shana, Proma, Pratiksha, Rakesh, Rishabh, Shoikat, Suprabho, Polomi. Good. Anvesha, did you understand? Good. So therefore you understand that therefore y like z will be more skewed towards 1. So if you put y is x is equal to z is equal to 1, वो आने का probability is always 1. Why? Because z is equal to 1 means x must be is equal to 1. If x is equal to 1, only y must be equal to 1. So therefore z आने का probability f will be always around 1. So that is an idea. So it will always happen like 1 के साथ it will always happen. So what is therefore कहाँ गया? So I'm trying to make you feel the problem, feel the dynamics of the whole thing that is happening. Otherwise, you'll not understand the problem. So therefore, if you put 1 is equal to 0, like it doesn't imply the probability, but probability z less than equal to 1, like this will be more height. If you just differentiate it, this will be more maximum at 1. Okay, so ये 1 में 0 आ रहा है, maybe it's not true. Okay, maybe it's not true. यहाँ पर 1 पे 0 आ रहा है, so the height must be around maximum around 1. So maybe 2z, I'm not sure, I may be wrong. It's what I'm feeling like it will be. Okay, maybe 2z is the answer, I'm not sure. Okay, let's check that. But it seems like 2z is the answer, right? You understood? Logically. Else if you put z is equal to 1, like probability is like if the density is turning out to be 0, but around 1 only it will must be maximum, right? Because around 1 aneka probability is much better. Around 1 I'm telling, understand, is less than rather than 0 mein. Did you understand the idea? That maybe it's 2z? Like, I'm not teaching you option matching, but I'm teaching you that if you can understand the dynamics of the problem, maybe sometimes in the exam you don't need to do the like problem entirely, but here we need to do. You understand this? That maybe it's around 2z, maybe it's 2z. Does that make sense? Guys? Yes or no? Okay. Yes, yeah, of course, according to the current logic, yes. So how we can find this out? Tell me now. How we can find this out? So understand this very carefully. Okay, this is super interesting. So therefore, f of z is only possible if like, or let's try to understand probability z less than equal to z. It's only possible if or maybe you can try to understand, I'm just thinking. Let's say this. It's only possible if we have got probability like f of x z and we have got y is equal to 1. This is equal to this if this joint distribution of x and y of x is equal to z and y is equal to 1. Like x is equal to z and y is equal to 1. So you understand this. This can happen if, like, if y is equal to 0, then it will not happen. That means it can happen therefore if and probability of Try like this. Just give me a minute. So we know I don't understand I'm doing something wrong or not. It's turning out to be z times f of z. I think I'm doing something wrong. Or maybe I'm correct, I don't know. I'm doing something wrong maybe. Just give me a minute. Um, why given this? Did I do something wrong over here? Oh, let's try to find out something like this. I think I have done something wrong over here. But why is it less than equal to z? It means probability. I think this should work. Why it's not coming up? कुछ तो गलती किया हो. Okay, just give me a minute. Also, I understood this is not correct from the fact why it is not correct because its integration is not 1. Okay, so this is not correct. Something I'm going wrong. Just let me check. Okay. I think we are not considering this length, this part. Just give me a minute. So z is equal to z. Okay, I think we are not considering this case that, okay, so, okay, why is the problem I'm doing? Understand this very carefully. The problem is that Z, if अगर y is equal to 1 हो गया, it's fine. But what if this Z comes up again in some other toss of y? You understand? So we are not considering that sequence. Okay. We are not considering that sequence. What sequence? The sequence is that, yeah, I will tell you. What I am not doing is the following. What I am doing wrong, in fact, maybe I will end it here, or I will let you think. It's very easy. So the idea is that what I am doing here is, why is this not statement true? It's simple. Like, if we get x is equal to z, and then y is equal to 1, then we will get z is equal to z equal to z, right? And that's exactly the meaning of this. But the problem is something different. How we can get z? We can get z by again doing the toss once again, and we can get z next time also. So, but we are not considering that here. You understand? We are not considering the case that time also that can happen. Did you understand? So we are considering the case that this is the first time if it happens or not. What if it doesn't happen the first time? It happens the second time. What will be the probability of that? How we can define that? So f of z is equal to z is dependent upon other under, yeah, I mean, see, we can get z is equal to z in two ways. Once we get it in the first toss only, otherwise we do the experiment once again we can get it, right? So we are considering, this means that we are getting in the first toss only. That's perfect. But what we are doing, considering the second toss. So we are not considering the probability of the case of the second toss. That first toss you got x is equal to z and y is equal to 1. Let's call it x1 and y1. We got that. So if we get the case x is equal to z, x is equal to whatever, could be, and y is equal to 0, and next toss x is equal to x2 is equal to z and y is equal to 1. We are considering this case. We are not considering this case. Did you understand? It can happen that x1 is equal to z and y1 is equal to 1. Or it can happen x1 is equal to, or it can happen just y1 is equal to 0. And then here what can happen? It can happen that x2 is equal to z and y2 is equal to 1 again. So we are considering the probability of this case, but we are not considering this case, right? No, we didn't explore that. See, I explored that idea, but I didn't do it mathematically. So I told that this, I just wrote it blatantly. But this is where I did the mistake. What is the mistake over here? The mistake is that when I write this means that in the first step we have got only the success. But what if you didn't get the success in the first toss and then you do it again over here? We have not written the geometry PDF part. So this can happen like this, or it can happen also like this. y1 is equal to 0, y2 is equal to 0, and then we get x2 is equal to z and y3 is equal to 1. Did you understand? We can get this one, we can get this one, we can, but the problem for this is this f of x comma y z comma 1. For this it is what? Can you tell me? For this it is probability y1 is equal to 0 and this will happen. So this is independent. For this it is probability like f of y1 is equal to 0, which is half, times f of x comma y z is equal to 1. Here it is what? Half, again half, f of x comma y z is comma 1. Did you understand this, guys? It can happen in all the different paths. Is it summing out to be what? What is this summing up to be? I think it's summing up to be 2z square. Just let me check. But is 2z square? No, this is also not coming. कुछ तो गड़बड़ कर रहा हूँ. But this idea I'm doing. Okay, 2z square common. So this is why we are considering geometric part half half half. But this is true. I hope you understood this. So what are the ways we can do it? I think you understood this. Let me explain it again. How it can happen. Let me explain how we can get x is equal to z, z is equal to z. We can have like this, that we got x is equal to z and y is equal to x1 is equal to z and y1 is equal to 1 in the right way, in the first one. Okay? That's how we get x is equal to z is equal to z. Or in the first one, whatever x we get y1 is equal to 0. And then next part where we get that x2 is equal to z and y2 is equal to 1. Then we can get z is equal to z in the second toss if y1 is equal to 0. And then in the next one, y1 can be 0, then y2 also can be 0. And then in the third toss we get x3 is equal to z and y2 is equal to 1, y3 is equal to 1, and this can continue till infinity, right? Did you understand, guys? Or did you understand this idea? I hope you understood it now. So now we need to find the probability of all this, not the probability but density of all this. I think I am doing a mistake in that only. To find the density of all this. But this is coming out to be what? F of x comma y z comma 1, right? If it happens in the first step only. Given that it happens in the first step, this is that. Given that it happens in two steps, means the first में y is equal to 0 आया, y1 is equal to 0 आया, and y1 is equal to 0 आने का probability क्या है? Did we calculate that clearly, guys? Did we calculate that properly? Y is equal to 0. y1 is y is equal to 1 आने का probability, I think we calculate that is ठीक से. Did we calculate that find probability y is equal to 1 is x half. So why is this not coming up? Anyways, let's try it out. It's half for this what? Into again this one, which is this is coming out to be z square. So this is z square, and then it's half square into z square. Am I doing this z square correctly? Yes, because this part is what? Given z is equal to this, x is equal to this, into f of x is equal to z. Oh, this was not z. That's why it's 1. Yes. This is not z, this is 1. This is just z. Yes, I made that calculation error. So f of this is what? F of z is equal to z, like f of x comma y of z comma 1. This is what? This is probability y is equal to 1 given x is equal to z into f of z, f of x of z. This is 1, I just written it 2, 1, z actually. So this is z into 1, so which is z. Did you understand why I did a mistake? So these are z, this is half z, this is half z, half square z. So when you add up all this, you get what? Twice z. Did you understand this, guys, now completely? Any doubts? Did you understand, guys? Yes or no? Which part you didn't understand? Bolo? Which part you didn't understand? Did you understand that this is equal to z and half square z? And this will continue. So when you add up this will what? Z common le lo, it's a sum of geometric then. Z into 1 plus half square plus half cube dot dot, which is equal to 1, which is equal to 2, and then z is there. Did you understand, or will I make it again? Tell it again. All of you understood it, guys, or will I again like tell it to you? Sure? Will I am ready to share it again. Please bolo if you did understand or not. Polymer, did you understand? Shuprabho, Shayana, Satej, Shoikot, Rishabh, Rakesh. It's okay not to understand if you don't understand this. I think Polomi is not there. She is not there. Okay, sure. Did you understand this is equal to Z? Satej? Okay, so now, did you understand that why it's like these are the all disjoint ways of getting that? Like how many steps? If you're getting in one step, the probability is Z. If you're getting two steps, that means first के लिए y1 is equal to 0, उसका probability is half, and next step is independence, so उसका probability is Z. if get in 3 steps, the first ka is 0 then half, second ka 0 half square, like half into half, and third mein you're getting that, so that's z, so half square into z. If you get in 4 steps, you get half z, so half cube into z. So you don't get it till infinity. So it's summation of z plus z, half z plus half square z plus half cube z plus half, yes. So it's z into 1 plus half square plus half cube, karte karte, so it's getting 2z. Do you understand, Shoykot? Shoykot, did you understand? Good. It was a good problem, no? So yeah, write a boom for this problem, those who are there till the last moment, if you enjoyed it. Thank you. Perfect. So this is a super interesting problem, and that's it totally involves the ideas of conditional probability, okay? And it's really beautiful. Okay. Thank you guys, and I hope you enjoyed the problem, and a very good night to you. Bye. Those who are new, please just wait for a minute, okay? So yeah, so perfect guys, and good night, and if I hope you enjoyed the problem, and if you liked it, please like it, share it, and share with your friends, guys. And we'll get back to you in the next problem solving session, and with the next problem solver problem a day. And we did some really good, beautiful problem. And in case you're looking for some crash courses, like problem-driven crash courses like this, do check the link below about our crash courses for IIT JAM MS 2022. Okay, all the best, guys, and I will see you soon. Next video. Stay tuned and stay blessed.